Welcome to Educational Village channel. Welcome to A-Level Chemistry. Today I am going to discuss nucleophilic substitution. Let's understand what nucleophile is. It is an electron pair donor that form a chemical bond during a reaction. Chemical bond is a dative covalent bond. Therefore, definition of nucleophile is an electron-rich species that donates a pair of electrons to form a chemical bond. Nucleophiles are attracted to positively charged or electron-deficient atoms. Simple definition of nucleophile is electron pair donor. So nucleophile can be a molecule such as water, ammonia. Oxygen atom in a water molecule has two long pairs of electrons. Nitrogen atom in an ammonia molecule has one long pair of electrons. Therefore, that can act as nucleophile. Negatively charged ion. Common examples: hydroxide ion, chloride ion, cyanide ions. All are having long pair of electrons. How nucleophiles work? I have already mentioned a simple definition of nucleophile is an electron pair donor. So nucleophiles have the ability to donate a long pair of electrons. So this allows nucleophile to attack electron-deficient species or electrophiles, leading to a formation of a new bond, which is dative covalent bond. Now this results in the displacement of another group in the molecule during the process. The mechanisms for nucleophilic substitution reactions: SN1 and SN2, nucleophilic substitution 1 and nucleophilic substitution 2 will be discussed in detail in another video. The general mechanism of nucleophilic substitution with haloalkanes. Haloalkanes are organic compounds that contain a carbon atom bonded to one or more halogen atoms. This is a general structure of haloalkanes. The carbon is bonded to electronegative halogen atom, making carbon partially positive and the halogen atom partially negative charge. Now, nucleophile attack the partially positive carbon and forming a dative covalent bond with partially positive carbon. Then, carbon-halogen bond, electron pair in a carbon-halogen bond moving towards the halogen atom. Nucleophiles substitute the halogen atom and form a new compound, and a halide ion is leaving. I will discuss few examples of nucleophilic substitution. In the first example, the hydroxide ion acts as a nucleophile. So the nucleophile attack the partially positive carbon in bromomethane and formation of dative covalent bond with the nucleophile and the partially positive carbon. Then the electron pair in a carbon-bromine bond moving towards the bromine atom and leaving as a bromide ion and formation of methanol. In this reaction, choice of solvent is important because different solvent giving the different the reaction pathway. In this reaction, use warm aqueous sodium hydroxide or warm aqueous potassium hydroxide as a reagent. In this reaction, cyanide ion acts as a nucleophile. Nucleophile attack the partially positive carbon in bromoethane and formation of dative covalent bond with the nucleophile and partially positive carbon, and bonding pair of electrons in carbon-bromine covalent bond. Those electrons are moving towards the bromine atom and leaving as a bromide ion and formation of propane nitride. Reagent for the reaction is potassium cyanide or sodium cyanide in alcoholic solvent and heat under reflux. Thank you so much for watching. If you found this video helpful, feel free to like, comment and share it with others. Thanks again, and I look forward to seeing you in the next video.